Hi everyone, I hope you are doing well so far. It's almost end of semester, and today I'm going to talk about mainly about the graph, and then also talk detail about the breadth first search and then depth first search. And so for graph, well, I think graph is a good tool to use because it's better like to. There's also another way to solve problem we can use to solve problem. And also, some people is better with visual than like code. So I think it's really good that they use it. They can use it. You can use it to solve problem, and then maybe you can code later after you solve the problem. Able to solve the problem. So first, let me talk about like the definition of a graph. The definition of the graph is that it's like a set of vertices and edges in a graph, and then the vertices being connected with by the edges. So like in here you can see that this is a graph G. It's a pair of G equals a VE. So where the V is like a set of vertices, you can denote as V1, V2, all the way to Vn. And then the vertex will be E, which denote as E1, E2, and all the way to like M, just to distinguish vertex and edges. So we use Vn and Vm, just like we don't know how many there is. Yeah, in general, but it will be a set of numbers in like the problems. So for the graph, there's a two type of graphs. There's undirected and directed. So undirected graph is like the edges set E consists of unordered pairs of vertices, and there are set E of equals of UV. So edges can be written with this notation, like it shows here, the curly brace UV. So when it's clear, clarity is desired, but we often use parentheses because we don't know the direction, because that's how the undirected graph looks like. So this kind of graph doesn't allow to have self loop because it's undirected, and also we cannot have a set of pairs like VV because no self loop, so you cannot loop back. And you can see in the picture that's show on the right, it is set of edges and vertices which is that get together, so it is a graph, and that is an undirected graph because there's no arrows in there. Yeah. Then I will talk about the directed graph. So the directed graph, which you can see in the, or you can call it a digraph. There are which is the edges that are ordered pairs UV. So you can see on the right side, there's arrows pointed from each vertices to other ones. Like from one, there's two edges out pointed to 4 and 2, and so on. And also there's also self loops allowed in the directed graph, like VV. Like you can see the example in the graph, the 6 has a self loop back to itself. And then there's some graph representation. So there are two types of graph representations: adjacency list and adjacency matrix, which is both shown in the picture. Adjacency list is showing on the left, and adjacency matrix is showing on the right. And then, well, I think there's also some example in a book. It might look a little bit different, but they're all correct. It just depends on which one do you prefer to use, and also the way to use like adjacency list and adjacency matrix to represent direct and undirected graph. They're also different from each other. And so now let me talk about the breadth first search. So the breadth first search is like a way to find the shortest distance from S to V, and then you have to also record if you visit all the all the vertices and edges, and because that way you can like trace back the path back. And the analogy of this is like a tsunami out from S that first reaches all vertices with just one edge from S, and then from them all vertices two edges from S, and etc. So like a tsunami, and you just reach all the destinations. Some can be reached at the same time, some cannot, will be reached later. So in this kind of search, you will use, or this kind of algorithm, you use FIFO, first in, first out, Q, like, and you use like a Q, like capitalized Q to symbolize, denote, to maintain the wavefront. And also, um, you can also use like colors to symbolize, like if you visit the verse yet, or it's still in process of visiting, or it's been finished, done process. Okay, so for colors, so for we use white. We can use white to symbolize that vertices have not been encountered yet. So it will be like original color because it would be like white from beginning. And then it will become gray. So that means the vertex has been encountered, but processing is still in progress. So like maybe you just been reached from the like other vertices, but it's still not finished process that, because that one still have like edges that can reach other vertices. Then you can leave it as gray and then maybe visit it later. And then once you the vertices has been done process, you'll become black. It's just a way to like symbolize um, which vertex you visit and which is not visit in the breadth search. And here is an example on the left, which is the some tsunami-like breadth like graph. From like in the middle will be center will be the S, and then you can go out from like other numbers like 3, 2, and then you go out all the way out like 5, 12, the universities. And then on the right, here's some Sudoku for the breadth search. I know there's another kind of Sudoku in the textbook, but yeah, this one is just use the way I just mentioned in previous, like in the video earlier, says like about different color for different kind of vertices, like the vertices you visit or still not visit, or you just already finished, you already finished process. So like white, it will be the one that still need to visit, and then gray will be the one that's in process, and then the black will be the one still finished process, which are all in this Sudoku already. And it just depends which one you prefer to use, because the both Sudoku will correct the one here and the one in the book. And then here it's the example for the breadth search. This one uses an undirected graph. As you can see, there's no arrow pointed to from any vertex or vertex or to any vertices. So which means it's an undirected graph. So let me explain how this one works. First, there is on the A, which means they started from the A step 8, step A. So they start from S, vertex S. They write a 0 for that vertex first and color it gray. And on the right side, there's a Q, which means the Q of this breadth search. So the first has the S in the Q, and then has a 0 under it, which means that's the one they started, the place they started with. And everywhere else, like all other vertices, will be infinity, because we don't know the number yet. And then step B, you see that S become black now because it's being finished process because it's a start point. And then there's two, because they can reach to two vertices, which is R and W. So then both R and W become gray, and it has a number 1 in there because that's the um, first type of first vertices that being reached from S. And then you can see on the right side the Q has W and R there, and the S is not there because it already finished process, and so it's being marked black, so it's not in a queue anymore. So because it's first in first out, that's how the queue works. And then we goes to step C, and then the step C you can see that because since there's two vertices being visited from S, so you can choose either one to continue. And in most of the time, you choose like the one that has more, can reach more vertices. Yeah, the vertices that can reach even more vertices. So compare the W and R. You see that the R has has one vertex that can reach from R, and there's a two vertices can reach from W. So we continue from W, and then you can reach two other vertices, which is T and X. And then that's why, and then after that, the W is become black. So that's why the W is not in the queue on the right side anymore. And then the two vertices from W being reached, which is T and X, they are being marked gray, and then being marked number 2 because that's the second set of pair of vertices that's being visited, and then they're both gray because it's still in process of being reached, so it's not being done yet. And then you can see on the right side the Q, because the R is still in processing, so it's still in there in the queue. It's not being finished yet because it's still gray. And then the numbers is 1, there's no change. And then there's two new one in the queue, which is T and X. And then it has the number 2 and 2 below them. And step D, then you can see once they finish the W, they go back to R because that's the first one that's been reached. So you still have to finish that one before you go to the second one, which is the letter that has 2, so which is T and X. So you go back to R, and then from R you can reach V. So then the R become black now because it's finished process, and then the reach V, and then V will go on to the Q, and then you will still has the T and X in the queue as 2 because this one is not, those two ends are still gray, and then now V come after the T and X, and then it's also 2. And then on step E, you can go choose either one, but according to the order, you have to choose the T first because the first come first out, first in first out. So then you have to choose T to go from T to other vertices. So T can reach to U, and because the X is like reached at the same time by W, like it's reached by W and same time as T, so that's why you don't need to, you can reach from T to X again, and then so you just can only reach U from T, then it will be marked 3 because that's the next one that being visited, and then T becomes black because it's already been finished process, and then U will become the gray one because it's in the process, in the progress process of in progress of processing. And then